Hello, we are Artificial Person Technology team. We would like to present a prototype of our product. It's a software development tool that creates a software code in accordance with the specification. Our team is confident that our solution is completely new and unprecedented solution. We do not use machine learning principles and technologies that are based on neural networks. We believe that current AI technology is still very far from being able to replace the meaningful work of the programmer. Meanwhile, the code created by our prototype is indistinguishable from one written by a human programmer. How did we achieve this? We are psychologists and have been studying for a long time how human thinking works. And then we were able to reproduce it in program code. Yes, we literally made a digital copy of a programmer and put it in our product. And now we will show what it can do. We will give to our prototype a specification written like it will be written by one programmer explaining the task to another. The specification is following the language rules and an eternal chain of reasoning. Otherwise, our system can understand various formulations. When the prototype receives the specification, it will analyze it and immediately begin writing code. No coffee breaks. This human feature is not included. And our prototype has a number of other advantages over humans. It does not make mistakes. It needs less payment for his work. It does the work of several days in seconds. After the prototype writes the code, compilation is completed, and that's it, the solution is ready. For now, the prototype codes in Java, but it can be taught any programming language. Since this is still a prototype, it has some limitations. It creates a Spring Boot application using the capabilities of the Spring framework. It is trained to use basic operations when working with DBMS. It isn't trained to create a graphical interface. Despite those limitations, the writing code will already be fully operational and ready to be embedded in the more complex solutions. But less talking, let's go. Let's see how the prototype will analyze the specification, write the code, and give us a ready-to-use solution. What you see is a simple interface with which we can give the prototype a specification. And this is the specification. As you can see, it is written in simple English and describes a typical problem, which allows us to show the current prototype functionality. I will change a couple of parameters to show that the details of the task can be any. I will rename this class to Avenger, because why not? I hope it's still relevant. Then I add the new class. And again, why not? Rename the characteristics. Add the new data type. And finally, I will add a couple of actions to this operation. Now copy and paste into the interface window. Let's go. When creating the prototype, we did not optimize for speed. Our priority was visibility and ease of debugging. So for now, creating a solution takes several minutes. In the finishing product, the creation of such a solution will take several seconds. It's done. Let's download the archive and look at the finished code. The result of the work of the prototype looks like a set of Java files ready to run. Many files ready to run. You can download them from the link under the video and make sure that there is no difference from the code written by a human. Expect that there are fewer comments than a human would leave. Please note that the whole solution is created by our prototype. The folder structure, the file locations, the files themselves, and all the code in them, from the names to the last symbol. At the moment, our prototype is the only one that creates solutions of this level. Now let's take a quick look inside our prototype to understand how it works. As we said before, we developed a technology that imitates the thinking mechanism of a human programmer. One of the most important parts of the solution is a semantic network. It stores the data the same way it will be stored in human mind. No, there are no neurons. There are concepts, categories, and sequences of actions related to each other as they are connected in the memory of a trained person. In this tab, we see the concepts from specification. They are the result of the work of our algorithm, which forms an understanding of the specification and reflected in the segment of the semantic network. Here is our Alive Avenger, which we recorded before launch. It is connected with such a concept of object-oriented programming as a class. At the top of screen, you can see the number of nodes, relations, and structures. This is the amount of prototype current knowledge. In the next tab, we can see what our prototype knows and can do. This is a set of standard skills that a programmer must have in order to write code. Perhaps you're thinking, what are those strange letters shown on the screen? It's Cyrillic. We decide to teach it in Cyrillic for several reasons. Each of these inscriptions refers to a sequence of actions that the programmer performs when he writes the code. It contains integrated complex actions, such as, for example, the declaration of the DTO class, and very minor actions, how to register a signature for a particular class, and even just put a semicolon in the end of the line. How did we teach him this? We just told him what to do when you meet a particle task and how to do it. Like if we were teaching a human student, we teach him as a human and we get the result as from a human. Several solutions based on our prototype can be brought to the market, and now we are deciding which to choose. If you are interested in cooperation, you will find our contacts below. Please share your thoughts in the comments and thanks for watching.